Hi everybody, we're going to go over one of my favorite free online graphing calculators here, this Desmos, D-E-S-M-O-S, desmos.com. Absolutely wonderful. You can use this throughout any middle school, high school math grades. Pretty much it can do anything that your TI-83 or other graphing calculators can do, and it's free, which is awesome. So we're going to jump right into it. We're going to start with graphing some cool patterns. It's going to be pretty open-ended, but it's going to be a really solid review for kids. So we're going to start with the 7th grade level, which is graphing lines. A great question to ask a student who is finishing 7th grade would be to just start out by having them give you an equation of a line. A lot of students might even just draw a blank at that if they're prompted it from such an open-ended standpoint. So lines either have X or Y or both in them, and let's give some examples here. This, I think, always is going to be your most classic line, your Y equals X. That means for every 1 unit on Y, you have 1 unit on X, so you have a very balanced line here that goes right through the center, and you have points that are going to be, always the same, no matter where they are for X and Y. If they're down here on the negative, they're the same. This would be the same as saying a slope of 1. That would be the same line. Then you could ask your student, okay, well, how could we change that a little bit? Well, boom, there you go. You have now a slope of -1. Or simply that y is equal to the opposite of x. So here, if you have x equals 2, instead of having also a positive 2 for y, you now go down and you have a -2. What I like to do when we look at functions in general, though, is to see them common patterns as transformations. And the common pattern here is that by adding the negative to any line, you are simply flip-flopping it upside down. So just like these two here, and we can turn off the first two. So this is now 4x, it's a very steep line, and -4x, which is equally steep but in the opposite direction. So you can start comparing these. Let's say we wanted to take this black line and raise it up a bit. So this is another common pattern that you should be emphasizing with your students throughout 7th grade, 8th grade, and throughout high school as well. The way to raise up any function would be to simply just tack on a number there at the end. Okay, so let's do a few of them. Just at the very end, when it's in y equals form, you just throw on a number. Plus 10 is going to move it up 10, and then we can change the +3 to a -3. Boom, you'll have another one going down. And let's end with, instead of 4x plus 10, we could do 4x minus 10. Boom. So each time you're moving the line up or down, that's called a vertical transformation. And that's a key word. Whether a student is in 9th grade or 11th grade, they should be thinking of these transformations because they work the same whether they're parabolas or sine waves. Once you know the common rules, they stay the same. So this doesn't look too interesting. If I was a little kid, I'd be probably not too entertained with this. So we did the vertical transformations. Let's see what we could do to make it a little, just a little more wow. So say you have a middle school student here, and you wanted them to graph something that was kind of neat. Let's say this here it's going to be more what your lines are going to look like out of a textbook. This is called y equals mx plus b form. For a review, the m is the coefficient of x, so here the slope is 2, and the b is that vertical transformation. That's the y-intercept that controls how high up or down your line is. If I change it to a 5, it moves up. If I change it to a 2, it moves down. So let's say we want to make some sort of cool shape here or what have you, some sort of some sort of star or something, okay? So what I try to get my students to do is to have a little idea and then play around with it, try to execute it. You know, you don't necessarily get it right the first time. But the great thing about this is that, you know, it updates automatically. So as the kids are tinkering with it, they can literally see how everything they're doing affects their work right away. So what would be the second half of this box here would be to have a negative slope with a positive y-intercept. Okay, and if I wanted to complete this, I would have the positive slope with the negative y-intercept. Okay, and then now let's just try to make that filled in even more. So we take these four, and let's just change them each to 5. And again, for each one, you kind of have a pair. You have, you know, 2 with positive slopes, 2 with negative slopes, 2 with positive y-intercepts, 2 with negative y-intercepts. So you can kind of see the pattern and see which ones are missing. As far as shading, you can bring in another really important content standard from 6th and 7th grade, which is inequalities. And that's going to shade one side or another in your graph. So if we change these equal signs, boom, to an inequality, you can see how it's shading inside your graph. If you wanted only the middle to be shaded, you would have to play around with these and kind of combine it until you get, see, that's not the direction we wanted, so we get that direction. Okay, and then we'll just keep going down. Nope. At some point, it does get a little dizzying. All right, the last type of line that's probably the easiest type of line, but the most forgettable type of line is, let's start over here. And how do you just do flat lines, straight across or straight up and down? Those are ones that don't have an x and a y. Those are lines that just have a y or just have an x. Those are going to be straight up and down. So how would this complete the box? You could have -2 and x equals -2. Okay, you could ask your students, well, how can we, you know, put an x through that box? Well, I think our basic line, boom, and its opposite, boom, would put an x through that box right there. Let's see, one final word about lines is that, let's review the transformations here. The first thing you can control is slope. So here you're literally just rotating a line. By changing the coefficient of x, you're changing the slope of the line, you're rotating the line. How can we get some shallower slopes in there? So don't forget that half of the slopes are probably fractions. You know, if a line is running more than it's rising, there you go. Then it's going to have a coefficient of x that is a fraction, or you can also write it as a decimal. So those two would be there. Let's get another shallower one in there. How can we have it? Let's see here, between the green and the purple, it would have to be slightly steeper than 1/2, but lower than 1. So let's try 0.8x and -0.8x. Boom. Okay, one more pair here, maybe by the x-axis, we can have a slope that is shallower than 1/2, so we can try 0.2 or 1/5, and negative 1/5 x. Okay, so that's one transformation, and the other transformation is simply up and down. So if I wanted to move everything on this up 2, I would add a +2 to everything, and of course that would mess it up at first, but let's test that by raising everything up 2 places. Boom. And that works. Everything has been vertically increased by 2, so y controls the vertical position. If you raise everything up by 2, it changes the y-intercept, but it more generally is just a vertical shift. Okay, so this basically sums up how to use Desmos as a review for linear functions. So this would be taking you up into the end of 7th grade, into the halfway through 8th grade. I'm going to follow up this video with the super cool functions like sine waves, parabolas, absolute values, and we'll see how the transformations as general rules are exactly the same.